So just kind of real quick about our team, in the last 2 or 3 years, SAS has put a focus on not just putting out software that customers can use to build models, but actually being able to build models ourselves, package those up for specific use cases, and put them out there for customers to use. So one of the ones I'm going to talk about today is an AML Alert Prioritization model that we're working on that we'll be releasing this year. So if you're familiar with this area, these challenges are not a surprise to you. High alert volumes coming out of your transaction monitoring system, especially a lot of them are rules-based. They're very black and white, yes, no, if-then type of logic. It can create a high volume of alerts. There's a lot of false positives. So one of the things that can be done to try to minimize the expense of dealing with that is trying to prioritize those alerts so that you can say, okay, these are the ones that are the most risky, so I want to send these to a specific set of investigators or triage people that might be trained to handle those in a more efficient way. This helps to deal with the inevitable impact of false positives. You're still having to review those alerts, but you're able to more quickly identify which ones are more likely to be false positives or less likely to be false positives based on the use of this model. So what we'll talk through here is our machine learning model that helps to risk rank the existing alerts that come out of the transaction monitoring system. So this is downstream from the actual alert process, the scenarios that you may have in place. It learns off of your historical data. So we'll talk a little bit about what we call a model pipeline, which is essentially what this is. It provides a process to take your data and basically send it through. At the other end, you're getting an alert prioritization model that you can then test and be able to use in production to prioritize your alerts in the most efficient manner. Controls and appropriate use, so we have things built into this like separating out kind of your classic approach to building a machine learning model, separating out training, validation, and test data to ensure that your models are being built in an appropriate way. All these things that your model risk management folks that'll be some of the first questions they ask. All of that is part of this process. We'll be talking about that in just a little bit as I go through the demo. This is supporting alert prioritization only, so it's not necessarily automating any decisions, but it's helping you to be able to most efficiently keep as we've talked about a lot throughout the last couple of days, the human in the loop. So how can we do that most efficiently so that you're able to kind of minimize the amount of time and expense that you spend on looking at all of these alerts? So I'll talk a little bit about the AML models that are coming out of our group. So we'll be focusing on the alert prioritization model here, but we do have one more that we have in development as well that I'll talk about in just a second. But the idea coming out of our group is that we provide what we call a model pipeline. So it's not necessarily that it's a pre-built model, but gives you the ability to more efficiently build a model on your data that is doing the intended process of building the model. So in this case, the alert prioritization model. So we include all the features that we use in the model, the data quality steps that look at your data, make sure that everything is looking as it should before you get into the modeling process, building the modeling data itself, building all the features, the target based on historical alerts. And then ultimately, at the end, a model tournament. So you can choose several different types of modeling processes to run through this modeling tournament. And then what comes out the other end is your champion model. You'll get all of the metrics around that you'll need to justify with your model risk management that says this model is good enough, and here's the proof that we have for that. So the alert prioritization model is as I described, a model pipeline. So you would be using your data, sending your data through it. It'll be trained on your data and be very specific to what you see, all the nuances of the data that you have in your system. We do have one more that will be coming out later this year. We're calling the cache model. So this is actually a model. This will also be a model pipeline that will be used to build a model to potentially replace some of your current rules-based cache-related scenarios. So a lot of the structuring type of stuff that everybody has to look for in their transaction monitoring system. So that will be a model pipeline, but we also have, with that one, we also have a pre-trained model that will come as part of that model tournament as well. With the alert prioritization model, we don't have the pre-trained model, but this does provide you a relatively seamless way to run your data through and create the model yourself. So before I get into the demo, just a kind of a quick rundown of what we have here. So we have three main steps that are a part of this end-to-end pipeline. They go from the source data that comes out of the SAS AML system all the way to the score code and the model metrics that you'll need coming out of the other end of the pipeline. So we have three main steps, one of which is the data quality check, often the most boring, but the most important step as well, because pick your cliche, but garbage in, garbage out, bad data makes for bad models, whatever you want to say. If your data's not good, then your models aren't going to be very good either. So this first step allows for an analysis of your transactional data, your account and party level data, to make sure that certain things are accounted for and are identified, so that before you get into the actual modeling process, if there is something that you need to change, you're able to do so. So that's the first step. Once we get through the data quality, then there's the ETL, or the extract, transform, and load step. This is where we create our modeling data itself, and we call it an analytical base table. So it's essentially it brings together all the features, the target, all the modeling, takes all the transactional data, the account data, the party data, creates these features, and puts it in the proper format to be able to run in a model process. And then the third step, which is the fun part, I guess, is the actual training of the model. And we'll walk through all these details here in just a minute, but you'll have the options for missing value imputation, variable selection, variable transformation, what types of models do you want to run within your model tournament, and then what sort of metrics might you want to see out the other end. Now, this is what I'm going to be showing here is a set of SAS custom steps that sits over top. It kind of overlays the model package itself. So what you'll see here won't be all the options that are a part of this, but a lot of the key ones that we've created these custom steps for, so that if you have maybe someone who's less technical that wants to still build the model, they can go through and pick through these drop-down menus to be able to run all these steps with relative ease. Now, if you have a data scientist who's maybe more technical, wants to get into the data a little bit more, or change some of the configurations, that is also an option within this pipeline. I'm not really going to get into that in the presentation today, but understand that there are options beyond what you'll see in these custom steps. If you want to add additional metrics to your model tournament, for example, that's an option there. All right, so I'm going to pull up. I put it in it's actually going to pull up a video of the demo because the Wi-Fi is not the best, so I wanted to make sure that we have this without interruption. So I'm just going to run through this video. I'll stop it along the way and kind of narrate what we're doing so that you have a better understanding of the process. But I guess before I really get started, so let me go back here. So this is in SAS Studio. If you're not familiar with this is kind of the core SAS product, where if you can build process flows, you can do SAS coding or other types of coding. You can run custom steps, which is what I'm going to do here. And this also connects to things like visual analytics and all the other SAS tools that you might have at your disposal within SAS Viya. All right, so the first step, we're going to open up the data quality step. We'll launch it. First is to choose the location of your data. So we have our alert data, we'll choose that. We have our core data, or the transactional account party level data. That's all stored in the AML core database within the SAS tool. We select where we want our PDF reports to output. We've got a set of about, I think it's 8 reports that you can see selected down here at the bottom, looking at things like completeness of the data, duplications, account party integrity. So if we have account data if we have account information in our data, do we have the details that go along with it? We look at things like transaction data integrity. So do we have transactions in the data that actually that are associated with an account or a party, where the date of the transaction is actually prior to when they became a customer or when the account was open. Things like that you just need to make sure that you've checked to ensure that you've got quality data that's going to be running through the model itself. So once we've gone through that, we hit run. This takes a few seconds to run. And what will come out here is one PDF for each of the reports that we've got listed here. You can choose some, you can choose all. And then we'll go through a couple of these here just so you can get an idea of what we're outputting for this first step. All right, so we've run it. At this point, the reports have been built. I've actually got a copy of the reports saved out here. So let's see. Let's look at the account and party data integrity report. So this is the general format of what you'll get for all these reports: the tables, number of records checked, and then a result. Does it pass or fail? So in this example, we do have, and just keep in mind, this is all synthetic dummy data that we have created for our development process, for our testing, and for demo purposes. So the numbers you might see here, if you're actually building these models, you're going to most likely have a much larger set of data than what we've got here. But if you look here, we've got 13,947 records in our account DIM. Of those, we have a lot of them, in this case 11,000, that do not show up in the profile fact table. So what that's saying is that the majority of the accounts that we have in our dummy data don't have account level details in the profile fact table. These are things just to be aware of. Now, you might go through this in your data and check that and say, well, that's actually okay. But just for the purposes of understanding your data and realizing what the level of quality is in the data, these are all important things to take into account. Same thing on the party side. We have a bunch of party records that are not showing up in the party profile fact table. Is there a reason for that? That's for someone to dig into, make sure that that's okay. If we look at, I'll look at one more here. Let's see, which one was it? I think that was the transaction report, I believe. So these are looking at things like the total number of transactions you have in your data, how many have a missing transaction date potentially, things like that, just so you have an understanding of your data. Are you looking at things like parties with a missing customer sense date? Those are some of the required fields that you would need to be able to run the model. So if they're not there, then you're able to go back through, have an understanding of what's in your data, maybe make changes prior to running the model itself. All right, so let's go back to the demo, and we'll move on to the next step. So at this point, you've gone through your data quality checks, you have an understanding of your data, you've made any necessary changes before you get into the actual building of the model itself. And actually, one more thing I forgot to mention here. So every time you run the data quality checks, as well as the modeling, it creates a set of PDF reports in a distinct directory. So you're not overriding the results that you had before. So if you do an initial data quality check, for example, and then you go make changes, you run it again, you'll have the new set of PDF reports to output, and you'll have that audit trail, if you will, showing over time where you've made changes and what the results were. Okay, so the next step we have the ETL step. So at this point, our data, we feel good about our data quality, so we're going to move on to actually build the modeling data itself. So again, we're choosing our alert data, we're choosing our core data, our transactional and party and account data, the location for those so that those can be pulled in. In this example, I have them saved on SAS data sets, but it does have the flexibility to pull from other places as well. A few filters here. So if you have multiple business units within your data, you can filter down to one specific one if you want to just build the model on that. You also have your date ranges here, so the data range for your transactional account party data, you can choose that. You can choose your alert range as well, so that you're focused on the data that you want to be focused on to build the model. If maybe you have data going back 20, 25 years, you don't want to use something that's 25 years old, then you can just subset it out here. So this will run and create the analytic base table or the modeling data. At this point, it still has everything in it. So once we get into the modeling, we'll be doing things like separating out our training, validation, test set. All right, so once we've got this, let's see, I believe I'll pull up the data here so we can get a quick look at that. So ABT data. All right, so this is generally what the modeling data looks like. So we have things like the alert ID, the primary entity number, other party level, account level details, And then as we scroll over here, so you see we've got 276 columns. So we've created a lot of additional things based on what the model needs. So we have some of these account level or party level information. And then as we move over here, you're going to see some of the features that we actually create based on the transactional behavior and that sort of thing. Let's see, scrolling over. So yeah, here we're looking at things like number of previous alerts between the last 1 and 30 days, number of previous alerts for this party 31 to 60 days ago, and so on, days since their last alert. We also look at things like the largest debit account, largest debit amount, largest credit amount, number of cash transactions, number of wire transactions, all kinds of stuff that are related to the scenarios, but not necessarily the scenarios themselves feeding into this model. So we've got, at this point, you've got your analytic base table or your modeling data ready to go to run in the next step, which we'll get into here in just a second. All right, so going back over to the process flow, and now we'll select the modeling step and launch that. All right, so now we've gotten into the modeling step, so we need to identify where is our ABT, our analytic base table. So go down here, select that. Important piece here, where's our target data? Conveniently named target in this situation. So we pull that out. Data partition, so we have a default here of 70-20-10 breakout, but that's an easy thing for you to change. Go in if you wanted to just do 80-20 with no test, or however you want to do it, you're able to do that, as long as it adds up to 1. And PDF location output, so we select that. You'll probably see here, we've been testing this a lot, so we've got quite a few archives here. But put the PDF reports in there. Missing value imputation. So you can do this on all the data. So we have it broken out by numeric and character variables. You can do it on all the variables. You can do it on some of the variables. You can choose different methods. So for numeric, we have mean, median, max, min, constant, standard deviation. You can choose multiple. So you'll see here in just a second, if I choose, let's say, median and max, then I can drop down and say, all right, which ones of my fields do I want to impute the median for, and I can select those, and then you go down to the next one and choose which ones do I want to use maybe the max for. Max is kind of an odd one I know to use, but it's an option here. You could use mean, of course, or whichever ones you want. Go through and select those. So I just go back here. I'm going to do missing value imputation on all the numeric variables, but I'm just going to use the median like a good statistician does. We do the same thing on the character variables. Select the mode here, but you can choose a constant. Same idea here. If you choose multiple ways to do this, then you have the drop down to choose which ones do I want to use the mode, which ones do I want to use the constant value. Variable transformation. So this is big, especially for our numeric variables. I'm going to pause it here for just a second. I know I'm running a little bit low on time here, but we've got, so we have 10 different transformations we can do, or we do on our numeric variables. We look at things like logarithmic, exponential, square root, normalization, a lot of those that it will run through this process, and then there's actually a process that will choose just the ones that have the lowest skewness. So if we're trying to normalize or not have too many extreme values, we're able to do that relatively easily. You have an option to bend your numeric variables if you'd like to do that. Again, to try to avoid some extreme values if you wanted to choose that as an option. For character variables, we do have a variable transformation for the character variables, which is changing the character values or the categorical values into the relative frequency of which they show up. Next step is variable selection. So we have a built-in supervised and unsupervised variable selection process that get merged together to identify the top 200 variables that we might want to include in the model. You also have an option, let me move back here real quick. You also have an option, let's see, where did I go? An option to specify variables manually. So if you don't want to go through a more of a rigorous variable selection process, you can choose it yourself. Final step, selecting the model processes that we want to run. We have 6 different options here, from the simpler logistic regression or decision tree to the more advanced machine learning approaches, gradient boosting, light gradient boosting, neural networks, random forest. And for all of those, you do have the option to auto-tune your hyperparameters. So we'll run through this, and then for the model tournament, you have the option to select what metric you want to use to determine the champion of your model tournament. Like I've said before, we have several listed here, but there is a configuration file that lives underneath this that more of your technical data scientists can go in, and they have more flexibility there in which ones they choose. But those are the 3 that we have in there for the custom steps. The validation mode, do you want to score and get your validation metrics, or do you just want to score your validation data that you can then export and maybe give to investigators to use to test out, see how well the model does in kind of a parallel run type of situation? And then finally, the risk-based segment. So we want to be able to rank order the alerts that are coming out of this. So we can look at it in terms of the top decile. If you want to look at the top 1%, however you want to break that down, that's what we can control here. So at this point, we've set all of our options here. We're going to run. I've fast forwarded through this part because this does take a while, especially if you're running multiple models, and doing things like auto-tuning can take a little bit of time. So we'll run through this real quick, and then actually I'm going to go ahead and escape out of this so that we can look at the model reports here. So what you get out of this is a set of model reports for each of the models that you create. So you're looking at things like the validation metrics for your forest model, the training, the score results for your forest model, your gradient boosting has the same, logistic regression, all of these, and then at the end of the day, you want to look at your model competition. So this is pulling in all the statistics that we have built in for the custom step right now. We selected the AUC as our model champion. So what this is telling us is that your gradient boosting with an AUC of 0.62 was the best model. Now that may not be that's not necessarily a great model if you're familiar with AUC, but that's the idea here, is that it's going to rank order based on AUC or KS statistic if that's your choice, whichever one you choose, and then determine that that's your champion model. Now if you're happy with this, great, you can go grab the score code or the ASTOR file and then be able to use that for scoring, put that into production. If you're not happy with it, you can go back through, change some of your settings, potentially if there are some additional data manipulation that you might need to do, go back through, be able to rerun this process in a relatively simple manner. Like I mentioned with the custom steps, this is more for someone who might want to be a little bit more point and click to get this done in a relatively quick fashion. But if you're more of a technical data scientist, we've got the configuration files that you're able to get into and make some of these changes that might be a bit more nuanced than what you would get in the custom steps. Okay, so that was all I had. Like I said, we're over at the Applied AI modeling booth, which is kind of back in this direction. If you've seen the worker safety demo, that's one of the models that we build. Come by and see us, come talk to me. And thank you.